The things that we had planned to do, or hoped to do rather, today that we did not get done was, first off, we wanted to get the IMP deployed. Now that means the IMP is on an astromast, and what we wanted to do was fire the pyro to release that mast and pop it up to its full extended height. The reason that we did not deploy it today was due to the airbag retraction activity and some of the other activities. We did not get a chance to take our what we call our insurance images, which basically is a set of images taken by the camera from its stowed height, so that if something were to go wrong during the deployment process, we would at least have a full pan of the surrounding area. So we wanted to make sure that we take those insurance images before we deploy the camera. So our plan now is to do that tomorrow. Sometime tomorrow afternoon. The other activity, of course, is we did not get a chance to drive off the rover. The major issue that we are still working right now is we have an issue with rover to lander communications. The first health check, or the first couple health checks, we did get good data from the rover, but we have not been able to get communications from the rover since then, and Jake will hopefully be able to add a little more to that. That's it for the lander.
Okay. I wanted to review a little bit some of the things we've learned about this remarkable place that we have just discovered, give you some idea of what the thinking of the scientists on the team is, and some idea of the overall excitement among our science team, almost 100 strong, about this place that we've just landed at. Shown in this first image, this was released at the last press conference, we see a terrain that obviously has a series of dark rocks in it with light, sort of reddish dust that you can see here. In some situations like this over here, it almost looks like these rocks are imbricated one on top of another as if they were deposited in a high flood regime. And that's the early thinking that some of these rocks may be flood deposited, which of course is not at all surprising since this is the biggest flood in the solar system. Next one. It's a closer up look, and you can see these rocks look like they're sort of tilted on end with structure within the rocks as well. So some very interesting things to look at. Again, a reddish dust. There's different colors rocks. They're dark, but there is some indication in some of these areas that there may be some slightly different color rocks, as shown by red-blue ratios in these images. Next one. Again, off to the horizon, this site has substantially more relief than anywhere we have ever seen on Mars. We believe these are hundreds of meters that we're looking at here, and as I showed you earlier today, both of the Viking sites that we've been on have been remarkably flat. And so we actually believe we have an idea of where we've come to rest on the surface of Mars by looking at these hills in the distance and using the directions that those hills are, and I'll give you some idea of that. Next one. Finally, we do see a variety of different, not just rocks, as I said before, but finds as well. It looks like there's a variety of different finds in this site. There's this so-called cloddy material, which is kind of hard to make out in this, but it looks like it's a little bit more indurated than some of the real dusty drift material here, and there's some indications of almost sort of a white dusty drift material. So we have a much wider variety of materials at the landing site than we've seen at either of the other two Viking sites. And again, that bodes very well for our continued investigation of this site. Next one. So where do we think we wound up? Well, I would argue from what you're seeing on the horizon, we see large hills on the horizon. There's substantial relief at this site that we are not, and I repeat, we are not within any of these secondary craters. If we were inside a crater, we would see a nice bowl around us and we just wouldn't see anything out in the horizon. Certainly not things that look like they're that far away. So we have actually think that we are up out of this ellipse, which is the nav team's ellipse, somewhere off in this region here to the northwest of this crater, which we believe we have identified in the images. And this is a preliminary one. I won't go into detail, but perhaps tomorrow morning we'll have a more detailed description of why we think we are out on this plane out over here. I think that's it for the images. Just one other item. We have finally gotten an opacity measurement. That is how much material or dust lies in the sky. And as you all recall, there was some disagreement among the Hubble observationalists that were saying that we might see a deep blue sky and a very bright white clouds. It's clear we do not see that at all. In fact, what we see is an opacity of about 0.5, which is rather dusty, and probably, I guess Mars has the last word, as it always does. I was wrong on my prediction that it would be clearer than the Azusa Fire Day here in Los Angeles. It's about the same as that, okay? So we do have a dusty sky. It looks very much like Viking did. It's a salmon-colored sky, and that opacity is a bit higher than what we had expected, and that will reduce our solar power just a tad. And with that, I'd like to turn over to Jake Matejevic to talk about the rover.
If we can go back briefly to, I guess, the prior image might be helpful, showing the, back one to the, showing the, one of the early images of the rover and the, on the pedal. Yeah, that one. As a guy pointed out to you that in the confirming image that we took a little later, this section of airbag material has been brought down behind the rover's pedal. It now clears up an area in front of the this pedal, and gives us now another attempt at calculating the actual position where the front rover ramp would deploy. That ramp will deploy in this area at about an angle of 24 degrees, maybe a little shallower than that. So this is actually a very safe, would be a very safe deployment for the rover off the front of the rover's pedal. I think what Guy mentioned, there was still some obscuration in the rear. We also took some additional rear images after this pedal motion and airbag retraction took place, and we had some obscuration in that area of precisely the area where we were looking to get some confirmation, where the airbag material was laying over one of the rear ramps, a portion of the rear ramp. At least from the images that we did see, it looks as though that material has also been retracted, but we didn't get a full view of the ramp as yet. So we went ahead with the commands to actually deploy the front ramp, and as mentioned at the beginning here, that command went up. The confirming images have been were queued to be taken, but the data will not be returned until tomorrow morning during our first downlink. The second issue that Guy raised had to do with the problems we've had with communications between the rover and the lander. The way that's manifested itself has been in the form of a high percentage of garbled frames and transfer between the two modems. For those of you who are not familiar with the communication system, it's actually a radio modem system, one on the rover, one on the lander. The rover, as link commander, routinely and regularly interrogates the lander for commands, and the lander's modem is on from the early morning period till late at night, and actually acting in sequence with the rover, attempts to communicate, attempts to receive these packets of information that the rover is sending, and stores them and buffers them for transmission to Earth. The manifestation of the problem we've seen has been of the form where the rover has continued to try to send telemetry to the lander. Some of it gets through. There are more along the lines of communication sessions that set time, begin the acknowledgments associated with commands and telemetry sessions, but quickly abort about the time when the larger frames of data containing information about the rover's health, other status information as we go through the command sequences on the rover, the confirmation of the execution of those command sequences being reported by the rover to the lander. We tried one attempt to power recycle the lander's modem. That didn't seem to clear the problem at this last communication session. We're going to try several recycles or power recycles during the night. And of course, because the rover is power limited, it routinely and regularly power cycles its modem. So we're going to see if that sequence of activities over the course of the next several hours doesn't clear the problem by tomorrow morning. As Guy also said, we did queue the sequences that would stand the rover up. In all likelihood, the rover did not receive those sequences. This communication problem is severe enough so that sequence probably was not received by the rover. But again, we will not get confirmation of that until tomorrow morning's telemetry session. There's no danger at this point either for the rover. The release pyro events that we just did command that include releasing the forward ramp, releasing the rover, and releasing the tie down of the APXS sensor head can proceed without these other portions of the command sequences on the rover being executed. The rover is tied down even after these tie down cables are released. The rover actually has 6 wheels caged prior to stand up, so it's not going anywhere at any time over the next several hours. And we have full opportunity tomorrow to, once we've gotten the confirming data, to repeat this process of attempting to stand the rover up. But in all likelihood, what's happened today is when we get these confirming images, we'll see a front rover, a front ramp deployed, still a stowed rover on the lander's pedal, and an opportunity to try to drive the rover off the pedal tomorrow. So with that, I'll turn this over to Tim Schofield to talk about the ASI Thank you. Situation.